Hello. The Week 2 study guide has some more things to say about the SQL language. It starts out by telling us the correct pronunciation for SQL, which is that SQL, as in the acronym Structured Query Language. However, you'll sometimes hear North Americans refer to the language as SQL, and that is for historical reasons, because the language was originally known as SQL but had to change to SQL for legal reasons. Now, you will have heard me refer to Microsoft's Server DBMS as SQL Server, not SQL Server. The reason for that is, well, everybody at Microsoft refers to it as SQL Server, so I guess we should do likewise. Now, the study guide once again goes back to IT Jobs Watch, and what it's doing here is just emphasizing the relative importance in the job market of SQL in comparison with the other languages that we use in computing. Now, some of the languages highlighted here are general purpose programming languages that can be used to build whole database applications. SQL is not a general purpose programming language, it's a special purpose language. It's a language for defining databases, manipulating the contents of databases, and querying databases. XML is another example of a special purpose language. So you can see there the relative importance in the job market for those different languages. Now, you hear a number of claims about the nature of the SQL, the language SQL. In the study guide, we'll often refer to it as a set-oriented language, making the point that a single update statement can update a set of rows in a database in a single statement. A delete statement can do likewise. It can delete a set of rows in a single statement. So it's a set-oriented, it's a set at a time. Each a select statement, a query, retrieves a set of rows from the database. So it's a set-oriented language. Now, you will sometimes come across the claim that it's a non-procedural language, and really that claim doesn't really stack up anymore. In the early days, when relational DBMS were having a battle with earlier DBMS for supremacy, the set-at-a-time nature of relational database languages was considered to be one of the great selling points for relational DBMS. So this claim that it's non-procedural was often heard. And it's capturing the same idea. Non-procedural, making the point that if you want to update a set of rows, you don't have to write a procedure. You don't have to write a procedure or a program with looping and branching. You don't need a while statement and an if statement to find the rows or the records in a file that you want to delete or update. Whereas in relational languages, which are set at a time, you can do that with a single statement. However, now SQL, the language, has been extended, and it now does have branching and looping statements, and you can use these statements to write store procedures, which we've seen one very simple example of in the video that introduced the use of SQL Server. So to say it's non-procedural really doesn't make sense anymore, because you can actually write procedures, you can write store procedures using SQL. You often also hear that SQL is a declarative language. What do we mean by that? Well, it's the same sort of idea. Instead of having to write a procedure to go and get a set of rows of interest, we simply declare the set of rows of interest. Now, this claim that it's a declarative language often goes along with the explanation that SQL is based on a language called relational calculus. And we will have a bit of a look at that language later on. And when we do, this claim that it's a declarative language sort of makes sense, because you can see relational calculus really is a declarative kind of language. You simply declare the data you're interested in. You don't know sort of procedure for how to find it. So some claims about the SQL language, some valid and some not. The study guide at this point makes the point that this non-procedural declarative aspect of SQL is actually quite significant, and it did represent a good step towards more declarative, less procedural technologies being used in computing over what was used previously. And in fact, over the decades, we've seen a drift away from procedural technologies to more and more use of declarative technologies, and some of the technologies that form part of the XML family of tools are non-procedural. They are declarative in nature. So the move to SQL are part of the move to declarative technologies. Now, having said that SQL is a declarative language, we simply declare the data of interest in a query. We are going to provide to you a way of reading an SQL query as a procedure. We're going to give you a procedural model of query processing. We're going to give you a way of reading a query as if it were a procedure. So for example here, we will be saying to you, the way to make sense of this query is to start by looking at the from clause. In this case, the from clause is simply a single table name. Can be something more complicated than the from clause. Can be an expression that evaluates to a table, but the from clause will always evaluate to a single table. We will say to you that the way to make sense, and the reason we're giving you this procedural model, is to help you make sense of complicated queries. SQL queries can get quite complicated, but it's only by being able to read and understand them that you can avoid making errors with the use of SQL queries. So we will be telling you that the way to make sense of a query is to start by looking in the from clause. The from clause always evaluates to a single table. What happens then is that the where clause hops in and acts as a filter on those rows. So we start out with the customer table. We say we're only interested in those rows where the following is true, just those rows. And then for each row that survives the where clause, each row is passed to the select clause, which determines the output. So we will be encouraging you to think procedurally about making sense of what a query does. From first, where next, select last. So we're going to give you a procedural model, and the thing that's good about it is it'll help you understand complex queries, and the other thing that's useful about it is that you can be sure that the way that a computer processes or a database engine processes a query must always be consistent with the procedural view of query processing as provided by the model. Now that all might sound very complicated. When you actually see the model, you'll see, oh well, that sort of makes sense, hopefully, and it should help you make sense of more complicated queries. That's the hope.